Hello again. Our next problem, 7.28, says in the diagram AD bisects angle BAC and I is the incenter of triangle ABC. Furthermore, AB is 7, BC is 8, AC is 11. Find AI over ID. So I'm just going to mark some of these measures in the diagram. BC is 8, AC is 11. Okay, AI over ID. How can I get that as a nice formula that I can work with? Well, AI and ID, well, this ratio makes me think of the angle bisector theorem, especially since we're dealing with angle bisectors. And if we're dealing with the angle bisector theorem, then we're dealing with ratios. So, which triangle could I think of that would have a ratio of AI over ID? Well, I could think of the whole triangle ABC, but those ratios wouldn't get me ID or AI because the angle bisector theorem expresses the ratio in terms of the sides that aren't the bisector itself. But if I think about the fact that BI is the angle bisector of not ABC but triangle ABD. And if that's true, then we can express the following ratio using the angle bisector theorem. So the angle bisector theorem, you have to imagine BI is cutting the triangle through the angle B. So I'm going to take the two sides, starting with AB on this portion, and I can express that over AI. It's the side over here over the side that it's kind of like getting cut off with the angle bisector BI. So AB goes with AI, which means that the other sides that are going to match up are BD and ID. Well, this has AI and ID in it, and I want this to find my answer. So I can rearrange this ratio by multiplying AI over to this side and also by dividing BD to this side. And we are left with AB over BD equals AI over ID. If you're not quite sure of how that works, I encourage you to try to simplify this on your own using like standard multiplication and division. But we get this ratio, which means that, well, I know what AB is. AB is 7. That's a measure I know. So now I have to find out what BD is. How can I find out what BD is? Well, if I think of the other angle bisector in my problem, the one at AD, it's bisecting the triangle ABC. So if that is true, then I can make another pair of ratios using the angle bisector theorem on the triangle ABC. So instead of using BI as my angle bisector, now I'm going to use AD as the angle bisector. And using the theorem, we are going to have that the side AB corresponds with BD. And that's equal to AC over DC. And if you're unsure about how I'm getting these ratios, go back to the lesson on angle bisectors and look at specifically the video where I'm using the angle bisector theorem. So, now that we have this, again, I know what AB is. I know that this is going to be 7, so I have to find out what BD is. Well, I have BD here. I know what AB is. I also know what AC is, but I don't know what DC is. However, I know that DC is BD or 8 minus BD, since BC is the entire length. So I can rewrite this ratio as AB over BD equals AC over, and instead of writing DC, I'm going to write 8 minus BD. That way, now I can solve for BD when I start substituting. So, going ahead, we have that AB is 7. We have BD in the denominator. We know that AC is 11. And then we have 8 minus BD in the denominator. Using cross multiplication, we get 7 times 8 minus BD equals 11 times BD. Now this is going to further get simplified. 7 times 8 gets us 56 minus 7 BD equals 11 BD. Adding 7 BD to both sides, we get that 56 is equal to 18 BD. Then dividing by 18 on both sides, we get that BD is equal to, well, 56 over 18. They're both divisible by 2. So 56 divided by 2 gets us 28, and 18 divided by 2 is 9. So I know that BD is equal to 28 over 9. Now the rest of the calculations will be easy to work with. We know we have this ratio, and I'm going to clear off some of this old work here. Let's clear out some of this since we're done with it. And using the original ratio we found at the beginning, I know that AI over ID is equal to AB is 7 and BD is 28 over 9. Using keep change flip, we have that 7 times 9 over 28. 7 divided by 28 is the same thing as, well, 1 over 4. So this is just going to be reduced to 9 over 4. And there is our answer.